Good morning, viewers. This is Kasturi Day, and welcome to MouShauk. Today, I will discuss the Pascal's law and hydraulic press. Okay. Now, Pascal's law, we know that there are certain laws of the pressure in liquids. So, we have discussed this earlier. So, just have a revision of that. Laws of liquid pressure are that pressure inside the liquid increases with the depth. With the increase in depth, the pressure increases from the free surface of the liquid. The pressure increases. Okay. Now, when the pressure is same at all points in the horizontal level, pressure is same at the horizontal plane. If it is in the horizontal plane, the same plane, if it is, the pressure is in all the points, at all the points that will be same. Okay, in a stationary liquid. Now, pressure is same in all directions about a point inside a liquid. One point, if it is considered, then about that point, pressure will be equal in all directions. Okay. Now, at the same depth, pressure can be different in different liquids, but it increases with the increase in the density of the liquid. If the density of the liquid increases, the pressure increases, even if it is in the same depth, at the same depth. Okay. And a liquid seeks its own level. Okay. It searches for its own level. It finds its own level. Okay. Next is, what are the consequences of liquid pressure? We know that the depth, that means due to the increase in depth in the sea waters, the pressure inside the sea water, that will be more, okay, and than at the same level in the river water, okay. And then the dams, the wall of the dams, that is made broad, and at the bottom that be made thicker and broad at the lower levels, because to withstand the increased water pressure at the depth. Then water supply tank, that is kept at a higher level to so that the pressure of water in the taps that increases in the house. Okay. The sea divers, they wear the protective suit, a special suit, so that the seawater pressure, inside the seawater, the pressure, the deep inside the sea, the pressure of the water, that is more. To withstand that, these divers have to wear the diver suit. Okay, special suit, that is. Then the size of the gas bubbles, that increases when it rises from the bottom of the lake to the above, towards the surface of the water, because the atmospheric pressure that becomes the water pressure that becomes less when it moves up to the surface. And therefore, when the total pressure we consider, that will be in that will include the atmospheric pressure also. That is the atmospheric pressure plus the pressure due to the water column above it. So that will make the gas bubble increase in size when it rises from the bottom of the liquid to the surface of the liquid. Okay. Now today we will start discussing the transmission of pressure in the liquids by Pascal's law. Now, the pressure, what is Pascal's law? Pascal's law is the pressure which is exerted anywhere in a confined liquid, in a closed vessel. If the liquid is kept, the pressure exerted anywhere in that liquid is transmitted equally and undiminished in all the directions throughout the liquid. Okay, that is, it is transmitted in all directions equally without decreasing. Okay, undiminished, that is without decreasing in all directions, it will be same. That is Pascal's law. Now, let us go to the discussion. The pressure due to the liquid at a point in a liquid of density rho at a depth h below its free surface is, pressure is equal to, height we know is h, rho is the density, and g is the gravitational acceleration due to gravity, or you can say gravitational force. So that P is equal to h into rho into g. So the pressure due to the liquid at a point in a liquid of the density, if the density of the liquid is rho, and at the depth, if we consider the water column, the depth of the water column is h below its free surface, and the gravitational force is g, then pressure will be h into rho into g. Okay, the pressure difference between any 2 points x and y in a stationary liquid depends only on the difference in the vertical height between these 2 points. Okay, if we consider one x and another is y, the pressure difference of x and y, the formula will be same, that is h into rho into g. Okay, but in case of x, the water column above it will be less than the y is down, so the liquid column, the pressure, the water column will be more, so it will be h1 rho g and another will be h2 rho g. So the difference will be, the vertical height will be the difference. Okay, the pressure will be equal to the difference in the vertical heights about between these 2 points. Clear? If the pressure at one point x is increased by any means, okay, the pressure at one point, say x is there, if that point is considered, then the pressure at that point, if it is increased by any means, the pressure at other point, that is y, must also increase by the same amount. Okay, so the difference in pressure between the 2 points may remain the same. Okay, because see, the pressure of x and y will only increase what? The difference will be what? The difference will be their height. The height, if it is, the height is like this, but height of water column, okay? Then the vertical height, that is. So that is there, okay? And if the pressure of this height is increased, then the pressure of this height will also increase. Okay. Now, if the pressure is increased at one point, then the pressure at y point should also be increased by the same amount to keep the difference in pressure between the points x and y the same. So the pressure exerted by point x is equal transmitted to point y. Point x, the pressure which is exerted by the point x, that will be equally transmitted to point y. Therefore, this is called what? Pascal's law. So Pascal's law means what? Pascal's law states that the pressure exerted anywhere in a confined liquid is transmitted equally in all directions throughout the liquid, which will be undiminished in all directions. Okay, that is, when the fluid is completely enclosed in a vessel, or a pressure is applied to it at any part of its surface, at any part of its surface, as for example by means of cylinder or piston connected to the vessel, then the pressure is transmitted equally throughout the whole of the liquid, of the enclosed fluid. This fact first was recognized by French scientist and philosopher Pascal, and that's why it is known as Pascal's law, okay, in 1650, and it's called the principles of transmission of pressure in fluids, okay, and therefore this law is known as Pascal's law. Okay. Next, to see, it's a demonstration of the Pascal's law. Here we take a glass flask which has narrow tubes, okay, coming out from its sides and the bottom. Okay, sorry. So one will be coming out from the bottom, and other 3 will be coming out from its sides. Okay, and it is provided with an airtight piston. This is the airtight piston, and at its mouth, the flask is filled with water in such a way that each tube has the same level of water. See, the same level of water it has. Okay, in such a way it is filled that all the pipes have the same level of water. The initial level on each tube is noted by this dotted line, black colored dotted line. That is the initial level of the water. Now the piston is pushed down. Okay, when it is pushed down, the water will move into these pipes. Okay, and the jets of water will come out from all the pipes. Okay, And we can see it will, all the pipes, the jets of water that is coming out of all the pipes, that will reach the same height. Okay, that is marked by the red dotted line. Okay, this shows that the pressure applied to the enclosed liquid is transmitted equally in all directions everywhere inside the liquid. Okay, the jet that is coming out of the jet of water that is coming out from all the pipes, that will reach the same height. This shows the pressure which is applied on this water, that is in an enclosed liquid, enclosed water, that will be transmitted to all directions and equally. That's why the water height that is coming out through the in the form of a jet, that is at the same level. Clear? Next is application of Pascal's law. So first today we will discuss hydraulic press. Okay, so hydraulic machines like hydraulic press, hydraulic jack, hydraulic brakes, these all are based on Pascal's law of transmission of pressure and fluid. So today we will discuss hydraulic press. Okay, now what is the principle of this hydraulic machines? They act on Pascal's law in fluids or gas or liquid. Fluid may be gas or liquid mechanics. Statement that in a fluid at rest in a closed container, a pressure change is one part is transmitted without loss to every portion of the fluid and to the walls of the container. The principle was first enunciated by French scientist Blaise Pascal. By each hydraulic machine works on Pascal's principle. A small force applied on the smaller piston is transmitted to produce a larger force on the bigger piston. Okay, so this we will see in the hydraulic press. Okay, so first is hydraulic machine, the basic principle which it works on the hydraulic machine. Okay, the figure we can see, it's a hydraulic machine which has two cylinders, P and Q. P is a narrow cylinder and Q is a broader cylinder. Okay, and there are two pistons, A1 and A2. Okay, of cross-sectional area, sorry, two pistons, that is A and B, and A has a cross-section of A1 and B has a cross-section of A2. Okay, now if the cross-section area of A vessel is A1 and B is A2 and the weight is placed on the piston A, if we place on the piston A as F1, okay, then and F2 on, so we first press A1, sorry, we first put on weight on A as F1, okay. Now the pressure will be F1 by A1. P is equal to F by A. Okay, that is force or force by cross-sectional area. Okay, so according to Pascal's law, the pressure exerted on piston A is transmitted through the liquid to piston B. So if when this is pressed, the liquid which is pressed, that will move on to piston B, and it will put the upward force, which will exert an upward force on the piston B. Okay, so that will be what? If the upward force exerted on piston B is F2, then F2 will be P2 into A2, or you can say P2 is equal to F2 by A2. Okay, and this pressure, we know that how much pressure is applied on piston A, that same amount of pressure will be exerted on piston B. So therefore P1 it will be equal to P2. Okay, therefore what happens from the equation, first equation, see P1 is equal to F1 by A1 and P2 is equal to P1. Then second equation, third equation is P2 is equal to F2 by A2. So from all the three equations, we can see F1 by A1, that is equal to F2 by A2. As P2 is equal to P1, so F1 by A1, P2 value I'm sorry, it will be F2 by A2 is equal to F1 by A1. One and the same thing, as A2 is greater than A1 and F2 is greater than F1. Okay, as F1, A2 is greater than A1 and F2 is greater than F1. Okay, the force will be more. Force will be more. Here, A2, A1 cross section is less than A2. So a small force F1 applied on the smaller piston A can be used to produce a large force F2 on the bigger piston B. This is the principle of hydraulic machine, which acts on as a force multiplier. That is, force is multiplied here. Because less amount of force is applied on one piston, smaller piston, and a greater amount of force is carried out and pressing up. It is exerting an upward force, and that will be multiplied more than that of the given force. Okay, so on B. So this force is less than this force. This force is more than this one. Okay, so F1 will be less than F2. Okay, so this is the principle on hydraulic machine acting as a force multiplier. Okay, next. Finally, we have come to hydraulic press, or we can say Brahma press. Okay, why it's called Brahma press? Because it has been invented by John Brahma. Okay, now we come to the construction of hydraulic press. Okay, so here we can see hydraulic press, it works on Pascal's law. It consists of two hollow cylinders. One is P, another is Q. This is the P cylinder, narrow cylinder, and Q is the bigger cylinder, broader cylinder. Now, P cylinder is known as the ram cylinder, or P cylinder is known as pump plunger or a smaller cylinder, and Q cylinder is it is known as press plunger or ram plunger. Okay, there are two pistons, V1 and V2. Sorry, two balls rather, V1 and V2. Piston A and piston B are there. Piston A is on cylinder A, so cylinder P, and cylinder Q, it has piston B. Okay. Now, V1 valve is in the cylinder P, and cylinder Q has V2 valve. Okay. Now, the cylinder P has a tank or reservoir. Okay. It has a tank or a reservoir. Cylinder P is connected to a reservoir or a tank at the bottom through the valve V1. Okay. The area of cross section of cylinder Q is larger than that of P. Excuse me. Of the Q cylinder, it has a larger cross section than P. Okay. And watertight pistons A and B are fitted in these two cylinders. Okay. That is, one is A and another is B. A piston at cylinder P and B piston at cylinder Q. Now, cross-section area, I told you the piston A has cross-sectional area of A1, and cross-sectional area of cylinder Q, it has A2. Okay, respectively, the two cylinders are connected by a connecting pipe that is known as R. Okay. Now, when we press down, so how to press down the pivot or the piston A? By raising the handle H. If we raise the handle, or raised up the plunger A, a lever arrangement provided with the handle is used. Okay, to press up or down. To press down or raise up the plunger A, a lever arrangement is there. Pivot arrangement, fulcrum arrangement is there. So for that, the cylinder Q, H handle is used, and the cylinder Q at its bottom is provided with the release valve, which joins to the reservoir. Okay, cylinder Q has a valve which is joined to the reservoir. So this is the valve which is connected to the reservoir. The piston is connected to fulcrum. This is H handle with a lever. Okay. To raise the piston or to press it down, this handle is used. Okay, this is the construction. Now we move on to the principle on which this hydraulic press or Brahma press works. Now F1 force is applied on the piston to exert a pressure on liquid containing in P cylinder. Okay, according to Pascal's law, this pressure is transmitted to the liquid in R to the piston B of Q cylinder. That is why the piston B tends to move upward as the area of cross-section of P cylinder is less than that of the Q cylinder. So by applying a small force on piston A, a large weight kept on piston B can be lifted. When no weight is placed on piston B, it rises up against the fixed groove with force F2, where F2 will be greater than F1. If a bale of cotton is kept on the plastic, it gets compressed. So what is the thing? How does it work? Or rather, its principle on working. So here the piston is pressed. Okay, here the piston A is pressed inside the P cylinder. Now this water, the liquid which is here, that will move through the valve into the reservoir. It will move through the connecting pipe into the Q cylinder. And the Q cylinder piston, the pressure which is pressed on the piston A, that will be much less. Less pressure is applied on the piston A, that will force the liquid to move to the cylinder Q, and that will exert a large amount of force on this Q cylinder piston, that is piston B, to move up. Okay. Here, if we keep a small a thing to be pressed, okay, the heavy weight also, it can be pressed. It can be pressed because here is a fixed level where it will be compressed. Okay. So here we have seen that hydraulic machine, it works on that small force applied to one piston that will create a large amount of force to create an upward force. Okay, that principle is applied here. Okay, and when there is nothing is pressed here, when there nothing is pressed in the cylinder Q above this piston B, then it will move up. It will move up, and there will be a fixed level where it can touch. Okay, but this force F2 force will be more than F1. With force F2, it will rise up. Okay, but this force F2 will be much more than F1. Okay, so what will be its working? So first the handle is raised, then plumb plunger raised. Pressure in P cylinder decreases. Then what happens? Valve V1 opens upward. Then water from the reservoir tank pushes into the P cylinder by the atmospheric pressure. Then acting on the free surface of water in the supply tank. Okay, the handle lowered, pump plunger pushes downwards, V1 closes to the increase in pressure in P, pressure transmitted to R, pressure in R becomes more than Q, then V2 valve opens and water from P enters Q, press plunger is raised against the fixed groove, the bale of cotton on the plunger gets compressed. So what happens? What happens? See, first, H handle is pressed. Okay, H handle is pressed. Now, when it is pressed, the piston of A, it will move up. Okay, it will move up. So here is the pressure decreases in the P cylinder. Okay, When it decreases, the valve opens. The water from the supply tank reservoir that will move up into this P cylinder. How will it move? Because the atmospheric pressure on the sides that is the open reservoir, no? So here the water, it will press the water to move into this pipe into the through the valve V1 to go to the cylinder P. Okay. Now, after moving into this cylinder, the valve closes. Now, what happens? Here it is also closed, here it is closed. So this pressure will increase inside the cylinder P, the pressure will increase. Okay. Okay. And then when this it has entered into the water, and the water has entered into the cylinder, the handle is lowered. Okay, the handle is lowered. Then what happens? This pressure, it will move. The pressure is increased here. The pressure will move inside this connecting pipe. Okay, the connecting pipe, it will move. So first what happened? First the handle is raised. Okay, handle is raised. The plunger is raised. Handle raised, the plunger raised. P cylinder pressure decreases. Then the valve, the water will move from the reservoir to the valve, through the valve into the P cylinder. Now the handle is lowered. The handle is lowered, piston is lowered, and the pump plunger will move downward. V1 will close due to the increase in pressure in P. And what will happen? There will be the pressure inside the P cylinder that will increase. And that will push the water into the, into the R pipe. Okay, connecting pipe, that is R. Now from that R, it will move. When the R pressure in the R increases, then what happens? When the connecting pipe, the pressure increases, valve 2, V2 will open and the water will gush into this Q cylinder. And when it will gush into this cylinder, then it will push the plunger piston B towards the fixed point. And if the cotton is placed here, bale of cotton is placed here, it will get compressed. Clear how does it work? Okay. Now, when this thing is over, when the function is over, then what happens? The machine function over, the release valve opens. The ram press plunger gets lowered. Okay, release valve opens, press plunger gets lowered, and the water of the Q cylinder runs out into the reservoir. What happens? What will happen when the function is over? Okay, now what will happen? Okay, the release valve is opened. When the function is over, this release valve is opened. The water will move from here to the reservoir. The handle is lowered. Pressure will increase here. Okay. Gets lowered. The press plunger gets lowered and water from the Q cylinder will move into the. So this one, the release valve is opened. The pressure decreases. The water will move into this reservoir. Here, the press plunger, that will get lowered. So it will push all the water from this Q cylinder to move into the water supply reservoir. It will become normal now. So when again it starts working, first we need to raise the handle, okay, so that the water enters inside this piston, inside this cylinder. Okay, valve will open, it will enter, then the handle is lowered, then this valve will close, then there will be compression, pressure will increase in this cylinder, the water will flow in the connecting pipe. Then when this pressure increases in this connecting pipe, B2 opens, it will move to the cylinder Q, press the plunger up, and it will keep the, if a cotton bale of cotton is kept here, it will get compressed. And once the working is over, the release valve is opened, the piston B comes down, and the water will flow from this Q cylinder into the reservoir. Clear? Next, we move on to the uses. Now, 4 uses are there. That is, it will press cotton bales, goods like quills, books, etc. It will press them. Okay. Then juice can be extracted, or juice from sugarcane, sugar beet can be extracted by this mechanism. Then squeezing of oil from the linseed and cottonseed, that can be done from this by this mechanism or this press. And then monograms can be engraved on the goods like this. There's monogram that is engraved on this book. There's a book on which this monogram has been engraved. So these are all regarding hydraulic press, or you can say Brahma press. Now, next topic on this chapter will be hydraulic jack and hydraulic brakes. Okay, so next video will be these, and then atmospheric pressure are also there, how it is measured and all those. So till then, if you have any doubt, please to write in the comment box. You can also write in my email ID, that is KASTURI kasturi74@gmail.com. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And if you are a new viewer to my channel or not subscribed yet, please to subscribe and ring the notification bell, because that will notify you as soon as a new video is uploaded. Okay. And don't forget to meditate before you start your day. So we have not done the meditation, but please do meditate before you start your day. So let us meditate for just 1 minute and end this session. Okay. So think that a point of light is falling on you, and you are enlightened, you are feeling enthusiastic, happy, and interesting. You are getting interest in all what you are doing and becoming successful. So at the end of the day, you are thanking God for being with you and helping you in every step of your life. Okay. And be happy and joyful all the rest of your day, and obviously your rest of your life. Okay. So thank you for joining, and do thank God for being with you. Okay. So thank you.